So here we go. First example of factoring. Factoring, remember, factoring means take something big and write it as a product of smaller things. So we're going to take this polynomial and write it as a product of smaller ones. So the first technique and method of factoring is called the greatest common factor. So the first thing you have to do is figure out what the GCF of these two terms are. So you have an 8, you have a 20, you have x squared, and you have a y. I have to figure out what they have in common, and I'm going to remove it. So now with 8 and 20, again, the smartest thing to do is start with the bigger number and write all of the numbers that divide it. So obviously you don't have to write number 1. So 20 is divisible by 2. It's not divisible by 3. It's divisible by 4 and 5. I mean, 4 times 5 is 20. It's not divisible by 6, 7, 8, or 9. It's divisible by 10, and then it's divisible by 20. Obviously, you can divide 20 by itself, right? So these are all the numbers that divide 20. Now I'm going to start checking them against this dude and figure out the biggest one that divides him. Obviously, I could cross these two out. There's no way you're going to divide 8 by 10. It's kind of stupid. You can't divide 8 by 5 either. You can divide 8 by 2 and 4, but 4 is the bigger. Remember, you're looking for the greatest common factor. So I can divide away a 4. Now I have to see if they have a letter in common. He's got x, no x. He's got y, he's got no y. They don't have a letter in common. Unless the letter appears in both of them, there's nothing you can do. There's nothing. So the notes say, take the GCF and put it in the front and put big parentheses. Take each guy inside and divide each guy by the GCF. You are dividing it away from them. And now do this division. You will get to a point where you do this in your head. You'll see in the other examples I do. At some point, I'll do that. 8 divided by 4 is 2. X squared stays. 20 divided by 4 is 5. The y stays. This is factored now. I took the bigger thing and I wrote it as a product of two smaller things, right? This is 4 times that, and then 4 times that. 4 times 2 is 8, x2, right? 4 times 5 would be 20. So this is how you factor with the greatest common factor. So this is the second GCF example. A little more difficult. There's more going on. The numbers are a little bit bigger. And now I can see that I do have letters in common. So it's definitely going to be more complicated for me to run through it, but I'm still going to do it. So now again, I'm looking for the largest number that divides 18 and 36. Now, 36 is divisible by a lot of numbers. So this time, I'm going to hop over to 18. 18 is divisible by 18. Cut this number in half. It's always divisible. It's an even number, so you can cut it in half. So it's always going to be divisible by half. Now let's see. 18 is divisible by 2. It's divisible by 3. It's not divisible by 4 or 5. It is divisible by 6. 7? No. And 8? No. You have 8, 16, 24. So these are all the numbers that divide 18. Now I have to come over to here. 2? Yes. 3? Yes. 36 is divisible by 6? Yes. 36 is also divisible by 9? Yes. And guess what? 36 is divisible by 18. 18 and 18 make 36. So he's your winner. I could cross them all out. So the biggest number that divides 18 and 36 is 18. You have to be super careful. I mean, they're both divisible by 6 and 9. So it's really easy to screw up and pick not big enough. And I'll show you what happens if you do that. So that's that part. Now you have to do the letters. This one has x3. This one has x7. I'm trying to take away the same amount from each of them. So he only has 3, but he has 7. I can't take 7 away from 3. So the largest that you can take from each of them at the same time would be x3. So this is what you're going to divide away. So again, the rule is take this thing, take the GCF and put it in the front, put your parentheses, divide each of those. And you know what? It helps to do this. You're going to do this in your head at some point. because this is a lot of writing. But this is what you're going to do. We're going to do it in our mind in the next example I do. But this is what you do. He goes in the front, you put big parentheses, you divide the GCF away from each of those terms. Now, 18 divided by 18 is 1. Now, I got to be very careful with the letters here. X3 and X3 cross out. They're the same. And I'm left with nothing but a Y. If you want to put a 1 there, you can put a 1 there. You don't have to. Plus 36 divided by 18 is 2. So I put a 2 there. And then X7 divided by X3. Remember, you subtract them. 7 take away 3 leaves you with X4. So this is completely factored. Pardon my bad box there. All right, so I figured out my GCF. This is the largest number. Now, let's say you screwed up and put a 9 there. Let's say you didn't put 18 and you put 9. You would do 18 divided by 9 is 2. And then you would do 36 divided by 9 is 4. And here's how you know you screwed up. You see how you have a 2 here and a 4 here? 2 is divisible by 2, and 4 is divisible by 2. If you ever get numbers left inside that are still divisible by a common number, then what you picked out front is not large enough. 9 is not large enough. 6 is not large enough. You'll have numbers inside that still have something in common. So this is how you know you screwed up. This is how I know that 18 worked, because what do I have inside? A 1 and a 2. There is nothing that divides 1 and 2 other than a 1. So that's how I know that I got my greatest common factor correct. So you can always check at the end and see if the numbers have anything left in common. Notice Y and X. If I still had an X here, then I didn't take enough away. You have to make sure at the very end that what is in the parentheses has nothing left in common. All right, so one more example of greatest common factor. This one again has a lot more in common. It's got, X's and Y's, bigger numbers. I mean, they're not too big. So again, we want to figure out GCF. So again, I'm looking for the largest number that divides both. Again, I'll look at 16. It's divisible by 2. It's divisible by 4. 5, no. 6, no. 7, no. 8, yes. And then once you hit the halfway point, right? Half of 16 is 8. Then you just jump to the number itself. 16 is not divisible by anything else. It's divisible by 16. It's divisible by 8, 4, and 2. It's not divisible by 3 or 5. It's not divisible by 6 or 7 or 9. Okay? So now check against 24. 24 is definitely divisible by 2, but it's also divisible by 4. It is divisible by 8, but it is not divisible by 16, right? It's to cut it in half, you get 12. So 8's your winner. So the largest number that divides 16 and 24 is 8. Now you do the letters. You look for the common letter. They have X in common. You take the smaller one that you see, which is X3. Then you look for Y's. Oh, they have Y in common. He's got a Y. He's got Y1, Y to the first. You take the smallest one that you see, which is Y. You don't have to put the 1 there. This is your greatest common factor. Now I'm going to get more sophisticated with you here. You're going to put 8x3y, and you're going to put parentheses. Instead of me putting this underneath them, we're going to do the division in our head. I need to take this and divide it by that. So I'm going to do 16 divided by 8 in my head. That's 2. x5 divided by x3. 5 take away 3 is 2. And then I have y divided by y. They cross out. Now I'm done. Now I put the minus sign. Boom. 24 divided by 8. 3. x3 divided by x3. Here's x3. Here's x3. They cross out. y2 divided by y1 is y1. You see, you don't necessarily have to write it underneath and do the division. You can do the division in your head if you get to that point. If you need to, do what I did in the first 2 examples. Take this thing and put it underneath here, and put it underneath here, and do the division when it's all lined up. Or you can do it in your mind like I did. This is okay. All right, it's a lot of work to write it underneath and do all that division when you can do it in your head. Now check, look, 8 times 2, 16. X3, X2, X5. And the Y goes along for the ride. 8 times -3, -24. X3 goes along for the ride. Y times Y, Y squared. So when you multiply it out, you get the same thing you started with. Notice 2 and 3. Is there a number that divides 2 and 3 at the same time? No. The only thing that divides them is a 1. That doesn't count. All right, so they don't have anything in common. This is not a 2 and a 4 or a 2 and a 6. Do they have a letter in common? X, no X. Y, no Y. They don't have a letter in common. So I know that I factored it completely.